Hi, this is Ken. How's everything going? Have you had your good weekend? How's your Sunday? Have you prepared for your Monday? Well, today's kata is called bouncing balls. In the question, a child is playing with a ball on the nth floor of a tall building. The height of this floor edge is known. He drops the ball out of the window. The ball bounces 2/3 of its height. His mother looks out of a window 1.5 meters from the ground. How many times will the mother see the ball pass in front of her window, including when it's falling and bouncing? There are three conditions we need to meet. The first one is float parameter edge in meters must be greater than 0. The second one, bounce, must be between 0 and 1. And the third one, window, must be less than edge. There are two types of returns we need to consider. The one is if not all the three conditions are met, we should return -1. Otherwise, we should return a positive integer. Let's go through the example. So if we have the edge equals 3, bounce equals 2/3, and window is 1.5, the result is 3. What we can see is those three parameters matches the requirements. It returns a positive number. And in the second example, the bounce is not in the required range, which should be greater than 0 and less than 1. But in this example, it's 1, so we should return -1 since this doesn't match the requirement. Okay, let's go back to the first example. This 3 should be the times of the mother see the ball passes in front of her window, including falling and bouncing. I think the first time is a boy drops the ball out of the window and it bounces back, so this is the second one, and then it goes down, so this is the third time. Okay, I think this is quite straightforward. Let's go and actually do it. Right. I think the first thing we need to do is to have 3 condition checks to check the edge, bounce, and window parameters are in the required range. So let's do it. So first one is edge must be greater than 0. So if edge and bounce must be greater than 0 and less than 1. So we can write as it's greater than 1 but less than 1. And the third parameter should be window, that is less than edge. If all of them are in the required range, so we can actually calculate how many times his mother will see the ball, or it simply return -1 as here. Alright, let's calculate the time the ball passes through the window. Do you still remember how I analyzed the first example as why his mother sees 3 times here? I think we can have a function to calculate how many times the ball can bounce back above the window. Let's write it like this. Let's make it more clear as above window. Alright, and we pass 3 parameters in, and we plus 1 as a return value of this function. So first of all, this is actually how many times the ball can bounce back in front of her mother's eye. This 1 represents the first time because the boy drops the ball, so there will always be 1 time that his mother can see it. So let's actually work on the bounce time. First, the edge here doesn't represent the height of the window. Instead, it represents the initial height of the ball. If edge is smaller than the window, which means that the ball will never bounce back in front of her mother's eyes, so we can directly return 0. Right. Else, then edge is greater than window. Then what we can do is to say if edge times bounce is greater than window, we can return 1 because definitely they bounce back 1 time. and also have a little bit of recursive way to do it by using this as the initial height of the ball. Also bounce and the window. As given here, it says including when it's falling and bouncing. So I think for each time it bounces back, so we should contact it as 2. Alright. I think this is the only issue we need to fix. Let's have a test. I think we missed one condition here, because here we say edge times bounce is higher than window, then we try to calculate the next time. But what if this is not higher than window? Then we should say, okay, return 0 to say we can't see it anymore. Now let's have a test. Cool. The 4 initial test has passed. Let's have some random test here. I think we have solved this issue, but I think we have a little bit of chance to optimize the code a little bit. Have you seen this return here and here? They are basically the same, right? So instead of writing the logic like this, even though it works, we can revert it a little bit. So if we do it like this, then we actually revert the logic. Right, let's have a test again and see whether this matches. Okay, it proves again. Then what we can do is to, if we dig down a little bit further, we can find out this is the only condition we need to go through the next iteration. Otherwise, we just return 0 directly. So we can remove this part and put it here. There are only 2 branches here. So if conditions matches those 2, it will go through the next iteration to get more results and see what we can get, or it will directly return 0. Then let's have a test again. Cool, nice and easy. Let's submit and head to the next kata.